look at the Run LDA module. The Run LDA module will run an LDA model. Most of the model actually, the machinery for it is in another library called GenSim. However, we will do some other sort of surrounding code that is found in this new LDA Python module. New LDA basically allows us to do some processing, as we already seen in the previous example, as well as output some of the results of the LDA model, both in text format but also as an HTML file that we can view in a slightly more dynamic way. So I'll show you that in a second or in a moment. Let's look over the Run LDA module, since this will be actually controlling this sequence of methods that we apply. So if you look at it, once again, it should look fairly familiar, similar to what we saw previously, mostly just getting a path in terms of the beginning parts of the code, as well as creating the specific class we're going to use, an instance of that class, and then reading the PDF again, just like we did before, and cleaning it up, just like we did before. So we still apply the same essential steps that we did previously to clean up our text, to read it first, then clean it up, and essentially prepare it for analysis. But if you look at the line of code after line 39 here, things begin to be different. One of the first things that we do is create what's called a dictionary. Now, a dictionary is something in GenSim library, GenSim. It's a very powerful library that's been created to do a lot of natural language processing. It really supplements a lot of what's already found in the NLTK library. You can see in the comments it says dictionary encapsulates the mapping between normalized words and their integer ID. So essentially it's a way to represent what words there are in a text document in some kind of ID basis. So we need that to reference the words that we're going to be using. And so what we're going to do is actually, you can see here, we're going to grab the specific text again, and then try to find that word reference, and then create basically a word corpus. This method called doc2b, doc2 and BOW is basically turning a document to what's called a bag of words. So the corpus will be a bag of words. Now, a bag of words are basically using that token ID and token count that we got before. We're trying to essentially create a corpus which has a reference to all the words that we want analyzed. Essentially, it's creating a kind of container for all the words that are in a document. The order of those words is not necessarily relevant. In fact, for this particular analysis, that's not what we're going to focus on. So we want to create a corpus to know what are those bag of words that we are interested in. So we know something like about the frequency, the rate of those words used, as well as the kinds of words that are found. Now, the next step is called the LDA model, which is calling the GenSim version of LDA model. And that requires that corpus that we just created, some idea of the number of topics, and then also the dictionary itself, essentially to ID the words between that are actually analyzed. The LDA model is what's called a topic model. Topic modeling is a way to understand topics in a document. So Leighton Datchett's the LDA model is basically a way to use stochastic methods that sample your bag of words or your words to look at the frequency of those words, their relevance in their document, how often they come up, and the kinds of associations they have too, to know if there are terms in which they are related to. So for instance, think of a topic such as dairy. Dairy may have a lot of number of other terms that relate to it, such as milk, cow, those kinds of things. So what the model does is allow you to associate those words with those specific topics. So the topic model not only tells you about the words and their relevance to the document, but also tells you about how important other words might be related to a specific topic. The topics can be assigned manually by you, so when you apply, say, number of 20 topics equals 20, it should return to you 20 topics as part of that result, and it will give you a sense of those words that are used in topics, but it's up to you to assign what those topics are. That's something that you might have to determine as a researcher. There's ways to determine what the ideal number of topics, and I'll show you that in a second, in a moment. But first, let's just remember that the LDA model is something used for topic modeling. And then we're going to just create a string version of the number of topics here, just to keep that as memory, so we use it for the actual model that we save. So you can save the model as well. This is a way to preserve the model if you want to use it in future analysis, so you don't have to do this LDA model. I should state that a lot of this modeling uses text to essentially train the model and then applies the model for the analysis. This is basically a form of machine learning. It's using a stochastic statistical way essentially of trying to find patterns of words that inform us about topics. And so that means you may want to preserve the model so you don't have to always recurrently or consistently use it every single time. Essentially, it saves some time since you're already doing the training with the texts. We may send it more text, for instance, that are related to the text that we had sent it. So that's something we could potentially do. And we'll also try to look at the number of topics. This is the output that comes out of the model, and then we will add it to the new LDA, this kind of processing module that I built, which will then add the results, essentially the output of the LDA model, and then allow us to display it somehow. So let's look at that let's look again more closely about what we're going to do. So this part is all built essentially using, or this part I should say, using GenSim library, as well as the saving part and showing the number of topics. So the first thing that we need to build, or we did build in this case, is to add total return results. So when we get the results, if we look at the method there, if we go to the new LDA, you'll see that it's going to come back as some kind of essentially a form of dictionary that we want to break apart, a kind of mapping that we can then break apart to then extract the specific data that we're interested in, that being the term, the number of topics, and the value, which shows us how relevant a given topic is. So we're doing that essentially here. What we're going to do is create a dictionary that we're going to return. The first parts are nothing more than using RE library in Python, which is the regular expression library. That is a way to manipulate text. So the text actually is the results of the LDA model in this case. What we're going to do is remove things like extra commas from the results, remove extra white spaces, split the output on the plus sign because we'll get a plus sign output, and then iterate through the split text to retrieve the specific information we want, that being the value as well as the term, and then referencing it to A, which represents essentially the number for the given topic. So we'll have a referencing to the number as well as the term and topics in the outputs, and that will be added to the total output, which is assigned to the class level variable result dictionary. Okay, so that's basically what's going to happen there. Let's go back to run LDA then to see what else needs to be done. And the final parts are basically relate to things like saving the outputs, evaluating the graph, and then you're seeing a library called PyLDA. So this is a library that's used to do things like visualizations, LDA topic visualizations. You can see in the comments. So it's a way to show outputs in an HTML format, but also in a dynamic way, and I'll show you that in a second once we get output. And then we're going to evaluate the graph. So this part is actually a bit different than before in a sense that we're doing something that is not necessarily specific to the LDA, but allows us to evaluate the values of the LDA. So if we look at what that evaluate graph method's doing, so again it's back at LDA, you can see it's over here, and basically it's a function display number of topics using some kind of coherence score. So coherence modeling is essentially what we're doing. A coherence score allows us to understand how relevant or how strong a specific LDA model is. The higher the score, the better the model. So this informs us how many topics there might be in a document, or more likely to be. So it is a stochastic model, the LDA, so we'll never know completely or never have necessarily 100% accuracy. However, what we can determine is have a more likelihood of greater accuracy using a coherence model. So coherence model allows us to understand how relevant the number of topics we've chosen for an LDA is essentially. And so we're going to do that here. What we're going to do essentially is list through or create some lists that we're going to return the results. So we want two kinds of results: the coherence score as well as the actual LDA model we're going to use. And then we're going to iterate and create a new LDA model each specific time, append that model, create a coherence model, giving it information such as the actual LDA we're using, the texts, the dictionary that we saw before, and reference the the coherence score that we want, essentially telling it we want to get a coherence score from it. So what we're doing is creating a series of LDA models, iterating through the full range that we're going to analyze. So if you recall, I put 20 as the limit value. So it's going to run 20 times, create 20 models, and give us 20 scores. And we're going to keep those scores in a list and return them at the end.